Good morning, everybody. This morning we'll be talking about finding the probability of different situations. To start with, let's talk about what probability is. Probability we don't represent with the percent, which we've talked a lot about this year, but instead the decimal or the fraction form of the equivalent percent. So we're not going to use the percent, we're going to use the decimal form or the fraction form of that percent. So if the percent was 75%, you might see the probability looking like 0.75 or 3 out of 4. So the definition is helpful to help us understand what we're finding of probability. It's the likelihood of something to happen or an event to happen. And it's based on a scale of 0 to 1. Here's a number line to kind of help us figure this out. 0 would be like your 0%. If you're talking percents, 0.5 is what we'll use, or 1/2 can also be used. And that would be the equivalent to 50%. And 1 is the equivalent of 100%. The words we use, if it's not possible to happen at all, it's not even an option, 0 is the number, and we say it's impossible. It's not going to happen. If it's certain to happen, it's definitely happening, and that's a 1. And then, of course, 50%, or 0.5, I should say, we say it's as likely as not to happen. So it could happen, it might not happen, it's as likely as not to happen. Now these, we have some ranges down here. 0 to 0.5 we consider to be the unlikely range. It doesn't include 0 or 0.5, but it's any number in between. So you could have 0.001. That's not 0. It's really close, but it's not 0, so that would be considered unlikely. Other numbers would be like 0.2, 0.09, 0.45, anything in the range between 0 and 0.5. Same thing on the upper end. It's a range between 0.5 and 1. And that's considered to be likely. If it's over 0.5 and not quite 1, it's going to be very likely to happen. So some numbers you could see here would be 0.51. It doesn't have to be, it has to be just a little over 0.5 and it's considered likely. Like we mentioned above, 0.75. You could have 0.803, anything over 0.5 but less than 0.1, and it will be considered likely to happen. Some other definitions that will be helpful to in finding probability are the outcome, which is the possible results of an experiment. So what possible outcomes could you get? Like if you were growing a plant in science, one outcome might be that it doesn't grow. One outcome might be that it grows like you expected, at the rate you expected. One might be that it grows slower than you thought. In the sense of math, we might be thinking of like if you had a spinner, and let's say that the spinner is divided into 4 sections, and this section is red, this section is blue, this section is also red, and this section is yellow. What are your possible outcomes? Well, the possible outcomes are the things that your spinner could land on. So one outcome could be red, another outcome could be blue, and another outcome could be yellow. Those would be considered your outcomes. The event is a set of one or more outcomes. So it's what you're finding the probability of. Now let's look at an example, thinking of a number cube. A number cube, just a dice. So we got to think about all of our possible outcomes before we start. So what are some possible outcomes if I roll this dice, assuming that everything is represented once like every other dice in the world? What are some possible outcomes? Well, I could roll a 1. I could roll a 2. I could roll a 3 or a 4. I could also roll a 5 or a 6. So those are the possible outcomes of me rolling the dice. The event, like we set up above, is what we're finding the probability of. So in this case, the event is the probability of getting a 4. Another way we can write this is P. This is the shorthand way to do it. Parentheses 4. That doesn't mean P times 4. That means I'm finding the probability of getting a 4. Anything in those parentheses is what you're looking for. So to do that, the probability is always a ratio, which we've talked a lot about this year. 7th grade is all about ratios and proportions. When in doubt, see if you can use one of those. So it's the probability of the number of 4s, or the outcome you're looking for, over the possible outcomes. So the total possible outcomes. So how many 4s were on the dice or the number cube? Only 1 4. So I write down the number of times it's represented. Never write down the number. That's a very common error. You always want to write down the number of 4s on the cube. And we're going to put it over the total possible outcomes. How many outcomes did I have? I had 1, 2, 3, 4, 5, 6 possible different things I could roll. So my probability is 1/6, or if you were to write it as a decimal, and you do not have to, and we talked about this one, it's 0.16 repeating. So is it likely or is it unlikely to happen? It definitely falls in that unlikely range. So we would say that this is an unlikely possibility of happening. Okay, so still thinking about that number cube, let's practice finding the probability of rolling a fair number cube. Let's talk about the word fair for a minute. Fair just means that everything is represented evenly. There is not more than 1 1 on the cube. There's not more than 1 3 on the cube. There's 1 of each type. The spinner I did a minute ago looked like this. And remember I think it was red, blue, red, and yellow. This is not fair because red is represented more than once. It can happen, but it's not considered a fair spinner in this case. So when we think of a fair number cube, we're thinking that every outcome is represented once. So again, let's talk about these outcomes. If you were to roll a number cube, what would the outcomes be? Well, I could get a 1, I could get a 2, 3, 4, 5, or 6. So my total outcomes are 6 together. There are 6 different things I could roll. All right, let's look at number 1. We're going to find the probability and say if it's likely or unlikely, certain, impossible, or as likely as not are going to be our options. So the shortcut way to write it is probability of less than 10. So they're saying I'm going to roll, when I roll that number cube, I'm going to get a number less than 10. Let's consult our outcomes. Are any of these numbers greater than 10? They are not. They are all less than 10. And there are 6 of them. So I would say the answer would be I have 6 possible outcomes out of 6 total outcomes because I want each of these numbers represented that would be less than 10, which reduces to 1. Always reduce, always reduce. This would be considered certain to happen. If I roll the number cube, I am definitely going to get a number less than 10 because there are no numbers on that cube greater than 10. Over here, let's look at this one. We've got the probability of rolling a 7 is what that means. The probability of rolling a 7. Well, looking up at our outcome list, I don't have 7 represented at all. So if I roll that dice, I'm not going to roll a 7. There is not a 7 up there. Remember, the number you write is the number of times what you're trying to find shows up. 7 does not show up, so I write a 0. We never write the number we're looking for. How many possible outcomes are there? Again, there are 6 total outcomes, which would reduce to 0. This is not likely to happen at all. It is absolutely impossible. Oh, I ran out of room. So this is an impossible event. There's no way I'm going to get a 7. Unlike number 1, where if I roll, I'm definitely going to get a number less than 10. I am certain to do that. Okay, let's look at number 3. The probability of rolling an even number. So what even numbers show up on our number cube? We've got 2, we've got 4, and we've got 6. So how many numbers are even? There are 3 even numbers out of 6 total possible outcomes, which reduces to 1/2. This is considered as likely as not to happen, because remember, its decimal is also 0.5, which means we've got a 50-50 chance of this happening. So the words we would use is it's as likely as not to happen. Probability, looking at number 4, let's find the probability of the factor of 12. So we got to think. So factors are small, they make up 12. So what makes up 12? I could do 2 and 6 make up 12. 1 and 12 make up 12. And 3 and 4 make up 12. Of these 3 options, this one I don't want to use. Well, I don't want to use the 12. I definitely want to keep the 1 though, because I could say that's a factor of 12. As well as 2 divides into 12, 6 divides into 12. So again, factors are things that will divide evenly into another number. 3 divides into 12, and 4 divides into 12. 1 also does, and I crossed out 12 because 12 doesn't show up here. So I don't want to use that as one of my outcomes. But of my list that I have 1, 2, 3, 4, I have 5 different outcomes that could happen based off of my list above. So I would say I have 5 factors of 12 out of 6 total outcomes. This is likely to happen. It falls in that upper range between 0.5 and 1. Number 5, the probability of rolling a 5 or 6. So either one. So how many times is 5 represented? It's represented 1 time. How many times is 6 represented? It's represented 1 time as well. So I have 2 chances or 2 possible outcomes I could get from my number cube out of a total of 6 outcomes, which will reduce, always reduce, to 1/3. And if you recall, in decimal world, that would be 0.3 repeating, and that definitely falls in that 0 to 0.5 category, which means it's an unlikely event. It's an unlikely event. The last one I want to look at is the probability of a multiple of 2. So not a factor this time, but something that multiple of 2. So let's go through the list. We've got a 1. I can't, that's not a multiple of 2. 2 is a multiple of 2 because I can say 2 times 1 and get 2. 3 is not a multiple of 2. 4, yep, that works because I can say 2 times 2 and I can get 4. 5, no, can't times 2 by anything to get 5, not evenly at least. And 6, we've got 2 times 3, that will work. So my multiples of 2 are these numbers here. So I have 3 different numbers that show up on the number cube that I could roll. So I would say I have 3 different chances of rolling a multiple of 2 out of a total of 6 chances. And again, this reduces to 1/2. So this one would be considered again as likely as not. For this example, let's look at this. This is going to be an experiment. So what happened here, first of all, is I have a fair spinner. Again, the word fair means that everything is represented equally on the spinner and that the sizes of each pie section are the same. Now, please excuse my drawing. I tried as best I could to get them to be the same, but when we're dealing with math, sometimes if we're told something, we need to accept it even if it doesn't look like it, especially that works in geometry a lot. So if it says it's a fair spinner, even if it doesn't, the sections don't look like they are, it is. And I definitely, again, know it's fair because A, B, C, D, and E are only represented one time on the spinner. So the experiment I did was that I spun the spinner 25 times and I recorded my answers below. So when I spun A, I got it 6 times. I kept my tally marks and then did my totals. B, I got 5 times. I spun C 7 times, D 4, and E 3. Now, with an experimental probability based off an experiment, it's based off of your results. And these are my results. Okay? Before, we were just saying, what's the probability of an A? And in this case, the probability of an A was 1/5. But I want to base my probability off my results of my experiment. It probably won't be 0.5 or 1/5, but it could be. And if it's not, it could be really close. If it's not, that's okay, because it's again based off the experiment that was performed off of the results that I got. So let's look at some questions over here. What is the probability from my experiment of landing on D? So that's when I go to my result column and I look and I find D, and it looks like I got a D 4 times. So I'm going to do 4 because that represents how many times I got D. Now, what was my total? Oh, here it is, 25. I spun it 25 times. So it's the number of times the experiment happened in this case. And if I add all these up, they will total to 25. So 4 out of 25. Reduce it, it doesn't reduce. This is definitely less than 1/2, 0.5, and greater than 0. So this rolling a D, or landing on a D, I should say, was an unlikely event. Let's look at the probability of finding a vowel or landing on a vowel. So when I come over to my table, let's see, A is definitely a vowel. It happened 6 times. I'm just gonna make a little chart over here. B, nope. C, D, E, I've got as an option, and it happened 3 times. So the outcomes I got were A6, E3, for a total number of possible outcomes of 9. Those were my results between the two. So I put 9 over the total number of rolls, which was 25. Always over the total number, of spins. I'm still stuck in number cube land. Again, this is definitely less than 1/2. If you wanted to double check it with a calculator, feel free to, and you would get the equivalent decimal of 0.36 if that helps you see the range of 0 to 0.5 better. This is also considered an unlikely event. Now let's come down to P, or 3, the probability of a C or an E, okay? So again, C, I came up with a 7, or 7 times I got a C when I spun, and when I spun an E, I got it 3 times. So I have a total number of outcomes from my experiment of 10. So the probability of rolling a C or an E was 10 out of 25. Now this one reduces. These both share a 5. They both have a factor of 5. So if I take a 5 out of both, I get 2 over 5. And if you needed the decimal equivalent to help you decide if it was likely, unlikely, certain, as likely as not, all those different ones, feel free to, and that decimal would be 0.4. It's still in the unlikely range, but it's getting a lot closer to be as likely as not. Now, let's look at number 4. If you spin the spinner 40 times, what would be the probability of each of the above? Well, this is called making a prediction. So we're going to make a prediction. And to do that, we've got all of these probabilities are based off of ratios. So if I'm making a prediction, you're going to be using, drum roll please, use a proportion. Didn't see that coming, did you? Everything in 7th grade is about ratios and proportions. Don't forget that. So the directions have asked us to predict what the probability of each of the above would be if I rolled it 40 times. So let me get a new sheet of paper here and move this one over because I'm running out of room. And let's look at that. So if I come back and I make a prediction, number 1, the experimental probability, so the probability based on the experiment I did for landing on a D was 4 out of 25, okay? This part was the experiment part, which I got from here. And I'm going to make a proportion out of it and going to set it equal to what I'm trying to find. So it says if I spin it 40 times, well, is 40 my total or is 40 my results? 40 is definitely my total, just like 25 was my total number of spins. Remember, you want same units across from same units. So if I spun it this many times, I want the number of spins to be across from it over here. And then this would be your X. So to do this, again, just remembering how to do proportions, cross multiply. And divide. So what we're doing, we're saying instead of rolling it 40 times, I'm going to see what I will get. And I got 6.4. So if I roll or I spin, I forgot I'm spinning again. If I spin the spinner 40 times, I would expect to get D anywhere between 6 and 7 times because it's not possible to get 0.4 of a letter. So I would get D between 6 and 7 times. I'd probably round it down to 6 just because it's closer for rounding purposes. But it gives you an idea of what you might get. And then you could test it by actually spinning it 40 times and see what happens. It might happen, it might not. It's all based on experiment and chance. But that's a good estimate. Let's look at the second one. The second one asked us about the probability of a vowel. So I want to predict what the probability of the vowel, or how many times I would spin a vowel if I spun it 40 times. So again, I'm going to come back here and I'm going to use the ratio I got for spinning a vowel, which was 9 out of 5. I'm going to set that equal to, don't know how many times I'm going to spin a vowel, but I know I'm going to spin 40 times. Again, cross multiply. Set it equal to 25x. And find your answer. Use a calculator to help you. I got 14.4 equal to x, so that would be my probability. That would be the number of times I would expect to get a vowel if I spun 40 times. So again, anywhere between 14 and 15 spins I would get a vowel. All right, for the last one here, we found the probability of a C or E. So I'm going to first start with the experimental probability I found, and I'm going to use the reduced. I had 10/25 and I had 2/5. The reduced one's going to make your life a lot easier. Smaller the numbers, less room for error, less math, so much easier. And that's going to be out of 40 spins. I want to know how many times by spun I would get a C or an E, which is what that X is representing. So cross multiply. Divide by 5. And I should be getting 19, but I'm just going to verify because it's kind of early in the morning. Oh, no, I'm glad I verified. 16. My head is not awake yet. 16 is the number of times I would expect to get a C or an E when I spun 40 times. The last example I would like to look at this morning is another experiment that a class did rolling a fair number cube. I'm going to draw a picture of it so I don't forget what I'm doing. Squeeze that in there. So I'm using a number cube again. Again, don't forget the word fair means that each number is represented once and once only. So that means I have total possible outcomes of 1, 2, 3, 4, 5, and 6. So I have 6 different outcomes on the dice. And we recorded the results in the table. So if you look, every time the class rolled a 1, they got 15. Rolled a 2, 16 times. They rolled a 3, 17 times, a 4, 20 times, a 5, 15 times, and a 6, 17 times. Again, we're going to want to use our results column, okay? When you're doing an experiment or basing your probability from an experiment, you use what happened in the experiment, not the original numbers on the cube itself. Now, I know my outcomes. I know I got 15 once, or 15 for ones. I know I got 2 16 times. These are my outcomes. Okay, let's actually write that too. So your results are your outcomes as well. But I know how many total outcomes I have. Well, I have 6 total outcomes on the dice, but do I know how many times I did the experiment? It doesn't tell me. In the last problem, it told me I spun the spinner 25 times. This time it doesn't tell me how many times I rolled the cube. So to get that, I'm going to add up all of my results because each of these represents how many times I rolled. I rolled 1 15 times. I rolled a 2 16 times. So if I add these all up, it will give me my total number of rolls that I did. So I've got 5. I'm going to kind of group this a little different. 5 plus 5 is 10. And I see I've got a 7 and a 7, that's 14. So I've got 10 plus 14 is 24. And 24 plus 6 is 30, so 0. Carry the 3. 3, 4, 5, 6, 7, 8, 9, 10. So it looks like I rolled a total of 100 times. So 100 is the number of times I rolled. Now we're ready to do these problems. You always have to have your total first, along with your outcomes. Predict how many times, so we're going to be predicting, okay? Predict how many times a 4 will occur in 1,000 rolls. Wow, okay, definitely don't want to roll 1,000 rolls, and that's why making predictions can be helpful using proportions. So the first thing I need to do is figure out what's the probability from the experiment itself. So the probability of rolling a 4, let's see, I rolled a 4 20 times out of 100 rolls. That's where you always start. And you can always reduce this now to make your life a little easier. I definitely see this as reducing. That leaves me with 2/10, which will also reduce to 1/5. This number will be a lot easier to work with when we're making our prediction. Also, is this likely, unlikely, certain, as likely as not? What is this one? This definitely falls in that small range of unlikely. It's between the 0 and 0.5 range. It is not a very likely event to happen. All right, so 20 out of 100 reduced to 1/5. I'm going to take that probability from the experiment and I'm going to make a prediction. Remember, 1,000 is the number of rolls, which goes on the bottom over x. So cross multiply. And this time I'm just going to leave it, just because x is already by itself. I'm going to leave it to make my life a little easier. And how many times will that happen? Should be 200. And it is. So if I were to do this experiment 1,000 times, or roll it 1,000 times, I'm predicting I would get 4 from the dice 200 times out of 1,000 rolls. All right, number 2. Predict how many times an odd number will roll in 10,000 times. Well, again, I don't want to roll this 10,000 times. That's a lot. So I'm going to use proportions to help me figure this out. So let's first start by finding the probability of an odd number. Well, what were our odd numbers? 1 is an odd number, and it happened 15 times. 3 was an odd number, or is an odd number, and it happens 17 times. And 5 is an odd number, and it happened 15 times. So I'm going to start by adding up the number of times each of those odd numbers occurred. Again, my odd numbers were 1, 3, and 5, and I'm adding up the outcomes from those. So 17, 47, it looks like it happened 47 times. Out of 100. This does not reduce this time, so I have to leave it as is. And I'm going to set it equal to, I want to know for 10,000 rolls, how many times I will get an odd number. Cross multiply. And I'm just going to again leave it on this side and divide by 100, since x will already be by itself. And I know a little trick here, that if however many zeros are on the end, I can cancel that many out. So there's a pair, and there's a pair, and that leaves me with 4,700 over 1, which is just 4,700. So that's how many times, if I rolled this, or if I rolled this dice 10,000 times, I would expect to get an odd number that many times. That's a lot of rolls that we just saved ourselves. All right, on the last one, we want to predict again how many times a number less than 5 will occur in 800 rolls. So again, we got to first start out by finding what the probability based off our experiment was of rolling a number at less than 5. Not equal to 5, but less than 5. This is not less than 5, so I don't want to use the 6. 5 is not less than 5, so the numbers I'm looking at are the numbers and the results of 1 through 4. So I rolled a 1 15 times. I rolled a 2 16 times. I rolled a 3 17 times, and I rolled a 4 20 times. And we just need to get that total. And I'm getting 68. So I rolled the numbers 1 through 4 68 times. 68 times out of 100 rolls. Always start there. I know this one reduces because they're even numbers. You can always use a calculator to assist you to double check the reducing. But if not, they're both divisible by 4. That's the greatest. So this is also equivalent to 17/25. So I'm going to use this one to make my life a little easier when I'm doing my prediction. I'm going to take the probability from the experiment, which was 17 over 25, or out of 25 rolls, and I'm going to set it equal to 800 rolls. Remember, the number of rolls equal to the number of rolls over X, because I don't know how many times I'm going to get a number less than. That's what I'm trying to find. I'm trying to predict that instead of rolling the dice 800 times. Cross multiply, and I'm going to just keep it on the same side. So 8 times 17, and then we'll divide by 25, or 800 times 17. And when I do all that, I get 544 is equal to X. If we look back at this part, 17 over 25, that is definitely over 50%, 0.5. So that's a likely event to happen, that you're going to roll a number between 1 and 4. This one's in a likely event. Up here, this is really close to being 0.5, but just a little under, so it's still in the unlikely category. All right, back down to this one. So if I rolled this dice 800 times, I'm going to expect to get the number 1, 2, 3, or 4, 544 times.